Hello, this is a presentation about ending the inaccessible web as we all built it. My name is Brian Olendijk, or at BTOPro on pretty much every social source imaginable. So for that, let's begin. So first of all, who do I work for? I work for Penn State University College of Arts and Architecture's Office of Digital Learning on a platform called ELMS Learning Network. ELMS Learning Network, or ELMS, you may have heard of. It's been contributing to open source efforts for a decade now. It's crazy to say. 3 colleges at Penn State are primarily involved and supply 3.5 developers, though we're picking up 2 soon. There's 7 instructional designers that have a lot of influence over the platform, with another half-dozen faculty who are giving feedback that gets implemented very quickly. But we serve thousands of students a year and dozens and dozens of faculty and instructional designers, and get input from a larger community. This is really a grassroots type of a platform. So what is it? So it's not an LMS, learning management system. It falls into a classification of system that's generally called NGDLE, Next Generation Digital Learning Environment. So it's less about being a system and more about being kind of an ecosystem. So when we approach a problem, we're not adding a new feature to one product, so to speak. We're building out new products that all know how to work and talk together. So what does that look like for people? Well, let's say you go and you're going to add content to a system. You're going to make a course show up on the books. Well, that's a management system. So we have a rear-facing system that I go and throw in a resource and say, hey, there's a course called DMD 100, or any other number of courses. But that can have a very similar user experience for everyone interacting with them to where content actually goes out to learners. And so this might be a learning space that has some flexibility as far as the design considerations, where media can be uploaded, things like that. In that same tool set, though, again, taking this distributed approach, we might build a studio application. So this is a very different type of a tool, but yet it starts to become familiar because of the usability patterns. It's a lot faster to develop things the way that we're doing it as a result, because we're not having to reprogram user experience each time, and it allows us to work forward ahead of what people are experiencing at any given time by building out new applications. In NGDLE fashion, we then send all the data to another location. So you have a system dedicated to data. In this case, it's Learning Locker. Now, we do integrate with Canvas or traditional learning management systems. And so what that experience then looks like is that top bar is a mix of some things that are ELMS, some things that are Canvas, some things that might be Yammer or some other location. It's more about getting things integrated so that people have a best of breed solution. Okay, so all the background out of the way. One of the things that we made in pursuit of this was, hey, how do we get to our own other applications, right? We've got these rear-facing systems, and one of those is media. We have to deal with a lot of media in the arts in particular, and just in general with producing courses for the web. So we made a media system. So media system's one of our setups, and you can upload an image, and then I can pick all these different ways to put it in place. And our thinking was, well, okay, we want to make sure alt intro is there, all that good stuff. So instead of users putting HTML in place, what we'll do is this: we'll put these codes. And so this is like a short code that then goes into content, gets interpreted, and then out the other side comes your highly accessible audited HTML that does the thing that you asked it. In this case, image boxed, left light boxed. So that instead of having to write all kinds of href tags and HTML tags or understand JavaScript or CSS, you just copy and paste this and away we go. So that kind of established the baseline of this principle where we want to get instructional designers and faculty out of the business of HTML. However, they still are going to need to represent themselves online, and unfortunately, HTML is the best way to do that. So we needed to look to something far more advanced than what we had experienced previously. And so obviously then you need a picture of an Iron Man. because we're going to get into some crazy stuff, and this has kind of changed our opinion of the way at which we build anything. This is 2017 as of recording in August, and February of this year, we've basically made a fundamental platform shift as a result of this. So this is how we're going to achieve the end of the inaccessible web, because no matter how hard we've all tried, not everybody's an HTML expert. It's just not going to happen. So what are the desired outcomes of the efforts we started from February? So we want to streamline design workflows. So when you're building an application, there's a ton of considerations to take into account beyond user experience. There's user experience as you would see it if you are watching this, but there's also user experience for everyone, right? Universal design principles to ensure that screen readers, people with low vision, any number, on a phone, any number of modalities, that they're all going to work. So that takes a lot of planning and development efforts, and universities tend to have small teams. So we wanted to make content modeling design first. Then we wanted to eliminate as much theming, quote unquote, as possible. Whether that's, in ELMS case, it's a lot of the guts are Drupal, powering data, but we wanted to not have to have people understand Drupal in order to interface with it, or any backend system for that matter. We wanted to make HTML unable to be inaccessible. So that's a goal of what we're striving towards. And that probably sounds a little lofty because, you can make anything inaccessible, right? But you gotta shoot for our Polaris moment here, and take away certain aspects of HTML that we don't like that you have to throw in area language all over the place for people to use it, and that they have to understand the spec, and that you have to put in alt info and then have all kinds of validation systems to make sure it's the right alt info, all those things. And basically make HTML based on what content creators want to put in place, but that they don't need to know CSS, JavaScript, HTML, and be an accessibility expert just to get things accessible on the web. So what did we stumble across in Iron Man tech that can handle this? And so what we think that technology is, and is now a core part of ELMS Learning Network and all future development, is called web components. You can go to webcomponents.org and you can check out 1,100 or so publicly available components that are out there. For a very academic definition of web components are a set of web platform APIs that allow you to create new custom, reusable, encapsulated HTML tags to use in web pages and web apps. So basically, you can define your own HTML tags. That's the big takeaway from that. So if you are more developer-centric, we'll start by saying this is not Pattern Lab. Pattern Lab allows you to build these different, items from smaller items and templated design, and then you implement the templated design as opposed to the root HTML elements. It's also not Angular or React, although it's very similar at times to React, even if you're just looking at it at a code level. But it's not those. This is a level below those, basically. So this is more native to the browser. It's 4 parts of the browser and the specification for browsers technology that then allow you to have these custom elements that can, register on their own. And then you'll hear us use I'll use the word Polymer or web components interchangeably. They're not actually. So Polymer is a tool for developers that helps them build web components faster and with more reusability. So let's take an example here. So let's say we have awesome explosion. And so forever you would put an img src equals quote awesome-explosion dot gif, and you'd say width 20px and height 20px. Right? And if that meant anything to any of you listening, then that's awesome. But most people, that doesn't mean a darn thing. So what if, to get an awesome explosion on the page on the internet, I could just write awesome explosion, the thing I want, right? It's more semantic. Well, what if I wanted to change the size of an awesome explosion so that I could have tiny or small or big or epic explosions just by a single tag? Now, epic might encapsulate a whole ton of stuff. That might end up making that IMG SRC equals and point to the right place. It might make width like 400 pixels and height 400 pixels or whatever. But instead of having to communicate all that, I would just communicate to people epic. What if we could do color, right? So I could get a epic purple awesome explosion or a red big awesome explosion. And then we could combine these, right? So I'd have my awesome explosion tag with size big, color red. Sweet. But, all right, what use is this? Why should we care about this so much if we're, this is an accessibility thing? So for one, Google Earth is built on this. If you go to earth.google.com, you have to use Chrome at the moment. So it's only part of the promise of use the platform, which is the phrase given to web components. But if you go to youtube.com/new, this is a much better representation, I think, of what we're going for. And so, hey, show me what that looks like. So if you go to YouTube and you right click and you inspect, you're going to see these made up tags. If you're familiar with HTML, you're not going to see just div, or strong tags or blink tags if this is the early 90s. What instead you'll see, and I have arrows pointing to them, is you'll see all kind of custom tags. And so this allows the Google developers to reuse the exact same way something would look in styling, in accessibility, in function, in user experience, in area language, all of that with a single tag, as opposed to having to unpack and write that over and over and over again. And so ELMS is loaded with web components. So if you go to webcomponents.org, you can see some really awesome accessibility-minded components. So for example, a checkbox, you could click on the checkbox and you get the little tap ripple if you were on a phone, right? Because it's a consideration. You need to give visual feedback to someone on a phone. You need to give audio feedback to a screen reader. That's, you need to be able to tab, so you need to set focus correctly. You need to be able to hit the space bar or return to accomplish the operation. And it needs to look good for those of us that can see it. So there's a lot of considerations with a single checkbox. Well, what if we had all that baked into a tag that was paper checkbox? And so then we would just use paper checkbox and we'd get all of those affordances I just mentioned. So that's kind of the idea with web components. And then that you could use those components kind of anywhere very easily. So let's look at one that a simple one we put together. So this is a drawer. And so LRN Design Drawer is an icon. And so then the icon would have to have alt data in some capacity. And then when we click it, we want it to like fly out. And so if we were to hover it or we were to focus on it, you see we get our alt info. So a screen reader can hit it as well and know, hey, there's more information here. And then when we click it or tap or activate it in some way, then a drawer opens up. And so then inside the drawer, you'll see is that p tag content. This is some help text. So not to get super technical, but like what is it that makes that happen, right? So this is a web component. The end. No, we're going to zoom in on a little bit, right? So basically you get these four parts of any component, and a component is just like the name of the component.html. So in this case, you have lrndesign-drawer.html, and then you import other references to other components. So in the case of LRN Drawer, it imports LRN icons, which gives us that little happy ELMS snowflake. And also tooltip, which tooltip is the styling of that little hover event. Then from there, you're registering with the browser, hey, there's a thing called LRN Design Drawer. And so that way the browser knows, hey, I should do this, basically. And so then it can apply CSS styling. It can then actually apply other elements. So you can use elements within elements. It can do some data manipulation to kind of pass things from the tag down into the guts of the tag. So in the case of icon, if we list our tag as LRN Design Drawer icon equals play button, that then play button would get passed down into paper icon button correctly. Then we can have a definition of what all the properties that make this up. So in the case of icon, we say, hey, you're a string, and you have an initial value of this, or alignment, or alt text, things like that. And then we can use regular old JavaScript. And so because of these 4 things, and I'm not suggesting all of us sit here and build these today, but that would allow us to make something that is no longer a normal, root HTML element like a div or a span. We could actually bake all of the accessibility considerations directly into this tag. That's a pretty moment that we got going on there. And so what this ends up looking like, if you were to want to put down this awesome flyout that is accessible, then you could just put this on the page instead. So it would have LRN Design Drawer icon in network, and then alt information, which is see additional content. And then whatever we want to appear on the flyout would have this is some help text. This would get all the affordances of hitting escape to close out of it. We could wrap stuff in an aside so screen readers know that it's additional content as opposed to primary content. And another awesome thing that we get from this is we've effectively done a by reference pass, if you will, similar to that media, token, if you will, that we had in the beginning. But this is a file that we can update. And so let's say I'm not right. Let's say this isn't actually as accessible as it could be. We could work with a disability office or accessibility team to make this one element better. And then everywhere that element shows up, we don't need to know where it shows up. We don't have people scouring through thousands of web pages trying to figure out where we use the drawer type of components, copy and pasted from wherever, or in a CK editor, WYSIWYG field thing. Instead, we have a single file that dictates every aspect of how it should behave, and then that can be updated, and we know it's going to be updated successfully everywhere. So what are the cons? There's got to be one, right? Basically, it's really, really old browser support. So it does work in Internet Explorer and Internet Explorer 11 and Edge, and Firefox and Safari. However, they perform better in Chrome and Opera because of something called polyfills, which we won't get into. But as time goes on, they'll function even better and better. And the real, negative thing, if you will, is basically that when the browser goes to load, you get kind of this, it's called flash of unstyled content. So your content appears, it's not totally ready to go to users, and then within like a second or two, it's enhanced and it does all the same things that the other browsers would do. So, but it's still a consideration. It's definitely worth mentioning. So pros of this approach, we get separation of concerns, right? I can dig into that file, I can edit one of the 4 pieces of it, and I can know it's been updated everywhere. We can get into headless theming. So headless theming is effectively the system you have behind the scenes, whether that's a Drupal or a PHP stock system or a Python-based system, whatever it is, that it's not actually wiring and doing theming, quote unquote, for that system. You're kind of you have these design components, and then the back end sends the correct data, and the design components go, oh, I should present it this way. We can bake accessibility in, and because this is by Google, that started a lot of the web component movement via Polymer, they have a ton of awesome elements that do all kinds of things that are non-visual, so that you can get into things like A11Y keyboard keys is an actual tag, and you can say, hey, when someone hits enter, I need you to fire this event, and that event might be, closing the window or clicking a button or what have you. So there's lots of really good accessibility features baked into that, as well as the mobile first type of support. It's component driven, so you can easily swap things out inside those elements and repair them. If you're using Polymer, there's automatic documentation, which is really cool. So as you're building it, you're actually seeing the documentation built out, so you could communicate that to someone else. And that last one, which gets the gaspy face, which is framework interoperability. All right, that's about as deep as I can breathe. But so what that means is effectively we can generate design elements that are completely agnostic of what the thing putting them on the page is. And so whether that's ELMS Learning Network, whether that's a homegrown system, or Drupal, or WordPress, or Moodle, or Grav, or Sakai, or Joomla, or some static site thing, or a super custom just .html page, you could use the same design components and communicate things visually in the same way. And so we've started doing this. We started building out an ontology and elements that are all pedagogically focused and focused around the needs of education and educational systems. You know, everything from a button to an input field to an icon to something like an assignment, to the way that a person is presented, all the way up to things like how do we have discussions. And so this is, you know, a very sophisticated element. But in this instance, this little element that's shown here, that's comments, right? And it's 3 people commenting to each other and it's threaded. It is completely disconnected from any system. And so if you see at the bottom there, it says LRN says comment list source path equals data.json. So effectively that is how we tie into our backend. Now, obviously you still need a backend that's providing the correct information, and I'm not discounting that isn't a lot of work. However, if we now basically got an API as a developer to say, hey, this is the designed thing, if you send it this data, it'll just work. And so that gives you your separation of concerns as well as reusability. So this comment thing that we've worked on for our Open Studio platform that just went live recently to students, we could take the commenting aspect of that and drop it into a discussion board system. Or if we want to add commenting to say pages in our courses, that we easily now have a visual way of communicating that, and it's completely reusable. And again, you still need to do backend types of stuff, but high reusability. You can really see how this, you know, is kind of earth-shattering, hopefully. So if you're interested in learning more about everything, relevant links, you can go to webcomponents.org or polymer-project.org or elmsln.org, and look in our blog section. We've got some posts about the future of educational technology and just, you know, links off to our elements and things like that. So make sure to check us out on social media at BTOPro or at ELMSLN or at LRN Components or at HeyMP, as Michael Potter is another core lead on the project. But thanks for tuning in. If you have any questions, make sure to reach out.